Welcome to DNXT. Today's topic is TCP header. So let's talk about what is TCP. TCP is the transmission control protocol of the transport layer. Transport layer deals with two types of protocol. One is TCP, that is transmission control protocol. Another is UDP, user datagram protocol. According to the application that we are dealing, transport layer selects the protocol. So this transmission control protocol is a connection oriented protocol. It is very reliable protocol as it deals with error controlling. So it detects the error, retransmit the lost packet, and then only transport further packets. Okay, because of this it is slower than UDP, but though it is slower, it is more reliable. So where in the application where data is very important, loss of data is means data is quite crucial and loss cannot be allowed. In that case, transport layer always uses TCP. Okay, it is used in HTTP, HTTPS, SMTP, FTP, etc. Okay, so important aspect of this TCP is that it retransmits the lost packet. This feature is not available with the UDP. If the data is lost with the UDP, it is lost, you will not get it. But in TCP, retransmission of the lost packet is possible, and after retransmission of the previously lost packet, further data is transferred from the sender to the receiver. So for doing so, header has many fields. Let's look into header and its fields one by one. Okay, so header size of the TCP header is from 20 bytes to 60 bytes. So the total size is ranges from 20 bytes to 60 bytes, and the various fields in the header are source port number, which is a 16-bit number, and destination port number. So there are so many applications running in the sender as well as receiver, but your data belongs to which application, according to that source number is provided to your data. So source port number and destination port number will give you the first two field. The next field is the sequence number. What is happening in your TCP, that data is continuously coming from the application layer, of course via presentation and your session layer. Data is coming from application layer to the transport layer. What transport layer is doing? Transport layer is segmenting your data. So the data is collected in a sequence of bytes, and those bytes are then collected in segments. So these segments and these bytes are sequenced so that when receiver will receive this data, it will, according to this sequence number, it will arrange the data in a meaningful format. Okay, so sequence number is of 32-bit, which will help the receiver to arrange the data in proper sequence to get a meaningful data from it. The next is acknowledgement number. Acknowledgement number is the number which will give you, it is also a 32-bit number, and acknowledgement number will give you the number that receiver has received the data, and it will ask for the further data with the help of acknowledgement number. Your sender will not send the data unless and until it receives the acknowledgement of the previously sent data. We'll talk about these fields in detail in further slides. Let's quickly go through the all fields, and then we will talk about these fields in detail. Okay, DO is data offset, that means header length. Okay, so जो whatever data you are sending along with the header, what your transport layer is doing, your transport layer is segmenting the data. It's breaking down the data into small segments, and each segment is having its own header. Okay, so you must know, or the receiver must know, what is the length of this header and what is the actual payload. ओके, लेंथ कहाँ पे आपके हेडर का खत्म हो रहा है और कहाँ से एक्चुअल डेटा स्टार्ट हो रहा है. फॉर दिस पर्पस वी नीड हेडर लेंथ और डेटा ऑफसेट. Okay, which is of 4 bits, then 6 bits are reserved, and then another 6 bits are for your flags. There are different flags like urgent, acknowledgement flag, sync flag, finish flag. So we'll talk about these flags in detail in coming slides. Okay, then the window size. Whenever we are dealing with TCP, they synchronize, the sender and receiver will do three-way handshake, will negotiate the window size, will declare their own window size, and then decide at what speed you are transferring the data. Okay, so that window size is declared in this field by your sender as well as receiver का जो header होगा उसमें उसका window size declare किया होगा. Okay, checksum is for the identification of any error. If there is some mistake in the header, then that is controlled by the checksum. This is also for error control, as TCP main thing is your error control, your congestion control. Window size इसी के लिए discuss हो रहा है. Okay, so to control the congestion of the data, then error control करने के लिए checksum field is there, then urgent pointer. अगर आपका data में, आपके segment में some part of the data, suppose यहाँ पे this is the collection of bytes, is your segment. See up, if from 51 to 100 is your urgent data, so ये mark होगा by the urgent pointer. इसके लिए भी we have 16 bits. Okay, and then options and padding. If your header size is less than 20, then you will need to do certain padding for it, because less than that is not possible to send. So the header length is from 20 bytes to 60 bytes, and all of this has their own bits available for them to represent the different fields. Okay, now let's talk about next slide. Same thing, header, source port, destination port. Next field is sequence number. उसके बाद आता है acknowledgement number. Then data offset is nothing but your header length. Then 6 bits are reserved, and there are flags: urgent, acknowledgement, push, reset, sync, and finish. Then the window side is there, checksum is there, urgent pointer is there, options are there, and then actual payload means actual data that you are transferring through TCP. Okay, now let's talk about them in detail one by one. First is the source port and destination port. Port number. So what is port number? Both the port numbers are of the 16 bits, and we have seen already in OSI layer during discussing transport layer that port number, different applications use different port number. For example, your HTTP uses 80. Port number 80. Your HTTPS uses port number 443. Okay, so the 16-bit number, that means 2 to the power 16, you have 65,536 possible numbers are there. Okay, and this port number ranges from 0 to 65535. Total are 5536, एक 0 आ गया तो 0 to 65535 is the range of the port number. These port numbers are divided into 3 parts, that is well known port number. जैसे मैंने अभी बोला कि 80 is for your HTTP, 443 for is your HTTPS. तो ये जो वेल नोन पोर्ट है इनका रेंज है फ्रॉम 0 to 1023. दिस इज योर वेल नोन पोर्ट, नोन टू ऑल. Okay, then user port is from 1024 to 49151. This is your user port. And then dynamic port is from 49152 to your last 65535. Okay, so आपका ये जो पोर्ट नंबर्स है they are divided into different, for the purpose of using for identification they are divided into well known port, user port and dynamic port. Okay, so this is all about port number, which is a 16-bit. So source number, whenever my PC wants to send something, for example I want to open the web server, I want to go to Google and search something over there. So what I'll do, I'll start the session, I'll go on the Chrome and I'll type something. Okay, तो अभी वेब सर्वर में यूज कर रही हूँ HTTP, तो मेरा पोर्ट नंबर हो गया 80, बट दैट इज माय डेस्टिनेशन पोर्ट नंबर. My source port number is the port number which is assigned by my PC to this session. Okay, so that is given by my PC. So that will be also in the range from 0 to 65535. Okay, the next is sequence number. जैसे हम लोगों ने बोला कि it deals, this is a very reliable protocol and it deals with proper sequencing of the data. So जैसे ही application layer से मुझे data आया, I have arranged that data, TCP have arranged that data in a stream of bytes. Okay, so if this stream of bytes, collection of this stream of byte is my segment, and I have attached a header to my segment. Okay, so sequence number will give the track of the bytes जो ओवर द नेटवर्क, ये यहाँ से नेटवर्क लेयर पे जाएगा, डेटा लिंक लेयर पे जाएगा एंड फिजिकल लेयर पे जाएगा, जहाँ पे एक्चुअली इन bits it will get transferred, or via electrical signals it will get transferred, right? So when this will be received by your receiver, it will be received in with a proper sequence number so that these bytes are arranged in a meaningful way. So sequence number is a counter that keeps the track of bytes sent over a network. Initial sequence number, my PC will decide if it starts with 1000. Fine, it is starting with 1000, but next will be 1001, 1002, 1003. For example, I am transferring 100 bytes in this segment. So 1100 will be the number, sequence number of my last byte over here. So initial sequence number is generated randomly by TCP when connection is established. Okay, but then it is sequenced. ISN is used to identify the order of bytes or segments sent over the connection. The receiver uses the sequence number to send the acknowledgement. For example, it will check whether it has received all these bytes, and then it will send the acknowledgement number as 1101. Next, whatever is the last byte that is received by the receiver, next will be your acknowledgement number. That's what we are going to talk about in the next slide. What is acknowledgement number? It is the number next, means it is declaring that yes, I have received that byte number 1100, now send 1101. Okay, if I receive, instead of this acknowledgement number, if I receive 1050, that means this byte with this sequence number has lost. The receiver has not received this number byte, and hence I have to resend it. Hence the acknowledgement number helps in retransmission of the data. Okay, are you getting this? So that's what we are going to discuss in acknowledgement number. Acknowledgement number is n plus 1. If the last byte that I have received has the number n, then my acknowledgement number will be the next number of the last byte that I have received. It is also a 32, just like sequence number. Acknowledgement number is also a 32-bit number which indicates the next bytes that receiver is expecting. Okay, acknowledgement number is the sequence number of the next expected segment from the other end. It helps to detect the packet loss. Just now we have discussed कि instead of 1101, if it sends 1050, that means this number byte is not received by the receiver and the sender need to resend it. Okay, that is the error control done by the TCP. Okay, now let's talk about the data offset or the header length. This is a 4-bit length field, header length. Okay, it indicates the size of header itself कि कहाँ तक आपका header है ये segment में और कहाँ से actual payload, actual data start हो रहा है. Okay, it determines the boundary between TCP header and the actual data payload within the packet. Okay, so this is 4 bits, so range from 4 bit मतलब 1 2 3 4 0 0 0 0 to 1 1 1 1 हो गया 4 बिट. ओके, यहाँ पे इसका वैल्यू 0 है. हमारा पता है हमको हेडर लेंथ कितना होगा 20 बाइट्स टू 60 बाइट्स. सो मिनिमम 20 बाइट का हमारा नंबर चाहिए. तो यहाँ पे हम 4 स्केल ऑफ 4 यूज करते हैं, मतलब वी मल्टीप्लाई वॉट एवर द नंबर वी आर गेटिंग, वी विल मल्टीप्लाई इट बाय 4 टू गेट द एक्चुअल हेडर लेंथ. Okay, so 0 0 0 0 is not possible. 0 0 0 1 मतलब value in decimal is 1. 1 into 4 not possible. 0 0 1 0 मतलब 2. 2 into 4 8 not possible. Minimum number क्या चाहिए हमको 20. Okay, अगर 1 1 भी करते हो तो 3 होता है. 3 into 4 12. Again not possible. Okay, let's do this third 1 0 0 0. क्या है इसका? ओके 1 2 4. सो डेसिमल में ये बाइनरी का डेसिमल अगर हम करते हैं तो उसका वैल्यू आता है 4. 4 into 4 16. अगेन नॉट पॉसिबल. मिनिमम नंबर वी नीड इज 20. सो उसके बाद वाला डेसिमल क्या बाइनरी क्या आएगा 1 0 सॉरी 0 1 0 1. नाउ दिस 4 plus 1 5 and 5 into 4 is 20. सो एक्चुअल यहाँ से आपका हेडर लेंथ स्टार्ट होगा. दिस इज नॉट द वैलिड नंबर फॉर हेडर लेंथ. दिस इज नॉट द वैलिड नंबर फॉर हेडर लेंथ. मिनिमम नंबर यू नीड इज 5 because with the help of scale of 4 you will get the minimum header length, that is 20. Okay, so 20 is the minimum header length which must be there. Okay, so ये सबसे छोटा number that you can use for your header length till 1111. 1111 means 8 plus 4 12, 12 plus 2 14, 14 plus 1 15 and 15 fours are 60. So maximum header length is 60. Okay, so this is your data offset. This number ये फील्ड के ये 4 बिट्स will tell you the actual header length. Then reserve bits, 6 bits are reserved over here. Okay, they are always set to 0, but why they are reserved? For some future purpose. Okay, then next are our flags, very important. Okay, so flags के लिए there are 6 bits. एक एक बीट एक एक फ्लैग के लिए. अर्जेंट फ्लैग इंडिकेट्स दैट कि ये जो मेरा सेगमेंट आप रिसीव कर रहे हो, इस सेगमेंट में देयर आर सर्टन अर्जेंट बाइट्स, सम अर्जेंट डेटा इज देयर, so that don't wait for buffer to get full, don't wait for all the data or full segment to get received. Okay, immediately send this data to the application layer. Okay, that the urgent flag indicates. Okay, it indicates that some data in the segment is urgent, some data, whole segment is not urgent. Okay, some data in the segment is urgent and to be given to the receiver immediately and processed before other data. मतलब यहाँ पे sequential processing अभी नहीं होगा. Okay, सिक्वेंशियल प्रोसेसिंग के लिए टीसीपी यहाँ पे वेट नहीं करेगा, बिकॉज व्हाट अर्जेंट फ्लैग इज सेइंग दैट सम पार्ट ऑफ द डेटा, और वो कौन सा पार्ट है ये आपका अर्जेंट पॉइंटर बताता है. अर्जेंट फ्लैग इज ओनली टेलिंग यू दैट yes, this segment contains some urgent data. So what your receiver will do, it will look to the urgent pointer which will point out कि ये segment में से कहाँ तक का डेटा अर्जेंट है, और ये डेटा अभी अनसिक्वेंस्ड है. पूरा सिक्वेंस्ड डेटा मिलने के बाद प्रोसेस होके फिर अपर लेयर के पास जाएगा. इन दिस केस इट विल नॉट वेट फॉर ऑल द डेटा टू गेट प्रोसेस्ड, but it will immediately process this urgent data and send it to the upper layer or towards the application layer. Okay, so in this case data is delivered unsequenced as it is urgent. Okay, example, if you accidentally transfer wrong file during file transfer, you can set urgent flag to prioritize your abort session. You want to delete it, गलती से mistake गलती से आपने wrong person को mail भेज दिया. Even nowadays on WhatsApp also you can delete that. Okay, if गलती से message आपने wrong number पे भेजा है तो. So what you do, if you have transfer that wrong file, then with the urgent flag you can delete it. Okay, then next is acknowledgement flag. जैसे 3-वे हैंडशेक में जब आप सिंक्रोनाइज, सिंक फ्लैग एक है जो आप सिंक्रोनाइजेशन, एक कनेक्शन एस्टेब्लिश, सिंस टीसीपी इज अ कनेक्शन ओरिएंटेड प्रोटोकॉल, आप क्या कर रहे हो यहाँ पे सिंक के साथ कनेक्शन एस्टेब्लिश कर रहे हो. रिसीवर क्या करेगा, आपको एक्नॉलेजमेंट भेजेगा. ओके, सो या फिर अगर आप एक्नॉलेजमेंट नंबर भेज रहे हो, तो अगर आपके ये सेगमेंट में एक्नॉलेजमेंट नंबर आ रहा है तो दैट विल शो एक्नॉलेजमेंट फ्लैग. Okay, so it indicates that data is received by the receiver. Acknowledgement लेके आ रहा है मतलब data receive हो गया. Okay, receiver sends acknowledgement packet after receiving sync packet from the sender as a part of 3-way handshake. आपने सिंक का मैसेज भेजा, रिसीवर ने आपको एक्नॉलेजमेंट का मैसेज भेजा. तो अगर आपका सेगमेंट एक्नॉलेजमेंट का मैसेज लेके आ रहा है तो उसके ऊपर एक्नॉलेजमेंट का फ्लैग रहेगा. मतलब एक्नॉलेजमेंट का जो बीट, एक्नॉलेजमेंट फ्लैग के लिए जो बीट रिजर्व है वो बीट ऑन रहेगा, वो बीट 1 रहेगा, बाकी के सारे बीट क्या रहेंगे, 0 रहेंगे. Okay, acknowledgement packet contains the sequence number of the next packet. Okay, मतलब next packet acknowledgement number में नंबर आएगा कि next कौन सा बीट रिसीव होना चाहिए, लेकिन ये acknowledgement number लेके आ रहा है ये बताने वाला आपका acknowledgement flag होता है. Okay, the sender then sends another acknowledgement packet with the next expected sequence number. जो next expected sequence number है डेटा रिसीव करने के बाद उसके साथ आपका acknowledgement का पैकेट जाएगा यहाँ पे. So this is acknowledgement flag. Next bit is reserved for the push flag. पुश फ्लैग क्या इंस्ट्रक्ट करता है कि एप्लीकेशन लेयर को इमीडिएटली आपको ये डेटा पुश करना है. Though it is not urgent, but it is important and need to be pushed immediately. Used in application that require low latency and high throughput like video conferencing, online gaming. So latency इतना important नहीं है लेकिन quickly push होना data important है. Immediately आपको वो screen पे another person का video दिखना important है. So in these cases push flag is used. Push flag is sent by sending end when it has more data to send. Push flag bypasses standard buffering, ensuring that specific data segments are prioritized. For example, जैसे हम लोगों ने urgent flag में भी देखा, वैसे ही push flag में आपका data immediately push buffering के लिए it will tell that कि don't wait for buffer to get full. बिकॉज बफर फुल होने के बाद डेटा प्रोसेसिंग होगा एंड सिक्वेंशियली वो ऊपर के लेयर के तरफ जाएगा. Okay, what push flag is saying, don't wait for buffering, immediately push this data to the application layer. Okay, then reset flag. Sometimes connection अगर terminate हो जाता है तो ये जो in transit का डेटा है वो सारा लॉस हो जाएगा. ओके, सो आपको फिर से रीसेट करना पड़ेगा. फिर से मतलब reset flag है मतलब there is some kind of disturbance in the connection and you need to re-establish the connection. For this purpose reset flag is used. This is done to handle errors, timeouts, mismatches, refusal, restart a connection after device crashes. Either there is a problem in the device or there is a problem in the connection. You need to re-establish the connection. For that reset flag is used. If it is not used, then the sender will continuously send the data and the packets are lost. So to avoid it, reset flag is used so that receiver will understand that we need to do three-way handshake once again. Okay, sync flag पता है हमको, we have already discussed. It is used to initiate the connection between the two hosts. You need to establish a connection first because TCP is connection oriented protocol. So there must be a connection between sender and receiver. They must negotiate the terms of regarding the data speed and the other things, and then only data is transferred. So the first thing that is done during the connection establishment is the synchronization, and for that sync flag is set. Okay, it requests to establish the connection. Next is finish flag. Fin flag, FIN flag is finish flag, is indicates the end of data transmission. Okay, डेटा पूरा ट्रांसफर हो चुका है. नाउ वी नीड टू एंड दिस कनेक्शन एंड दिस मैसेज विल हैव द फिन फ्लैग. दिस इज सेंट टू इंडिकेट दैट इट हैज नो मोर डेटा टू transfer or to send, that it has completed all the data transfer. This flag is again acknowledged by the receiver. So receiver acknowledges fin flag with the ACK flag, मतलब acknowledgement flag, and sends its own fin flag. Okay, so this is known as four-way handshake. जब हम terminate कर रहे session, then four-way handshake is done between the sender and receiver with the help of finish flag and acknowledgement flag. Window size, as we have discussed in the starting itself, that window size is always discussed during the three-way handshake. Whenever there is an establishment of connection between the receiver and sender, they will declare their window size ki I have the capacity of receiving these much data. ओके, दैट इज डिक्लेयर. सो उसके बाद एक निगोशिएट करके एक स्पीड और एक डेटा लिमिट डिसाइड होता है बिटवीन सेंडर एंड रिसीवर, एंड देन डेटा ट्रांसफर स्टार्ट्स. ओके, सो बोथ सेंडर एंड रिसीवर will advertise their own window size in this field. Okay, this helps in flow control. It will avoid the congestion and the data loss. Then checksum, it will control or the check the error in the header itself. If there is some kind of header error in the header, then it is rectified over here. So this is the checksum field for the error detection in header itself. Urgent pointer, just now we have discussed in urgent flag कि if your segment contains certain urgent data, तो segment से कहाँ तक एक्चुअल में आपका अर्जेंट डेटा है, that is given by your urgent pointer. ऑप्शंस एंड पैडिंग, यहाँ पे MSS डिक्लेयर होता है, दैट इज मैक्सिमम सेगमेंट साइज. अभी विंडो साइज तो उसने डिक्लेयर कर दिया कि आई कैन एक्सेप्ट दिस मच ऑफ डेटा, दिस इज माई कैपेसिटी, मैं इतना एक्सेप्ट कर सकता हूँ. ओके, लेकिन एट ए टाइम कर सकता हूँ मतलब एट ए टाइम इतना नहीं पॉसिबल होगा, क्योंकि आपका सेंडर और रिसीवर के बीच कौन सा टाइप का कनेक्शन है, फिजिकल लेयर पे कौन सा टाइप का कनेक्शन है, that is also important. So MSS is maximum segment size. Window size will tell you how much total data it can accommodate. For example, it can accommodate 10,000 bytes. That is its window size. Fine. MSS will tell you at a time segment कितना बड़ा होगा. For example, its maximum segment size is of 1000 bytes. Then 1000 bytes के 10 segments you can send, तो उसका window size fulfill. Are you getting it? For example, आप अगर दिन में 4 रोटी खाते हो तो पूरे एट ए टाइम दिन में अगर आपका डाइट है 4 चपातीस, एट ए टाइम आप 4 चपातीस कैन नॉट digest. In the morning you will eat, for lunch you will eat 2, and for dinner you will eat 2. Of course, along with other things, I am giving you a crude example to understand. So 4 is what? Is your window size, and 2 is what? Your MSS. At a time, you can eat only 2 chapatis. Or for example, if you are eating 2 chapatis per meal, that is your window size. You are eating 2 chapatis per meal, then पूरे के पूरे 2 चपातीस मुंह में डालोगे क्या? नहीं. Okay, you will take small bites of it. Okay, so that is your maximum segment size. Okay, so at a time how much you can eat, you can swallow, that is your maximum segment size. And your full diet of one time is, for example, your window size. Okay, just a crude example to understand the difference between MSS and window size. Okay, I hope this is clear to you. Yes, this is all for TCP header. We will discuss UDP header in the next session. So stay tuned with DNXT. Thank you.